Here we have a problem on derivative. So there is an implicit function and we have to find dy over dx. Usually when a function is solved for y in terms of x, something like this, or 2x square positive 5. So this is explicit function because it has been solved for y in terms of x. But in our function, it has not been solved for y in terms of x. So it's called implicit function. Okay, now what we need to do is we have to find the derivative on both sides with respect to x, and then we have to solve for dy over dx. Okay, now let me write the given function as it is. That is ln of x positive y equals to x positive y. Okay, now let's differentiate both sides with respect to x. Okay, so whenever I find derivative of a natural logarithm, I have to write 1 in numerator, and whatever stuff in the argument of the logarithm should be written in denominator, that is 1 over x positive y. So this is the derivative of just natural logarithm. By chain rule, I have to do further derivative for the argument over here. So when I find derivative of this x with respect to x is just 1, and when I find derivative of this y with respect to x, it will just become dy over dx equals to, and now let's differentiate the stuff on the right side with respect to x. So the derivative of x with respect to x is just 1, and the derivative of y with respect to x is dy over dx. Okay, now we can distribute this 1 over x positive y to this 1 and dy over dx. So when I do so, when I multiply this 1 over x positive y and 1, I'm just getting 1 over x positive y positive. When I distribute this one to this, I'm getting 1 over x positive y times dy over dx equals to 1 positive dy over dx. Okay, now our aim is to solve for dy over dx. So in this equation, we have to solve for dy over dx. So for that, we have to get the terms dy over dx on one side of the equation. Already we have the term which contains dy over dx on the left side. So let's get for the term which contains dy over dx on the right side. For that, I have to subtract dy over dx from both sides. So when I subtract dy over dx from both sides, this positive and negative term will cancel out. I'm just getting 1 over x positive y, positive 1 over x positive y times dy over dx, negative dy over dx. On the right side, I just have 1. Okay, now let me write this equation as it is. That is 1 over x positive y, positive 1 over x positive y times dy over dx, negative dy over dx equals to 1. Okay, so now we have to keep only the terms which contain dy over dx on the left side. So, but this term does not contain dy over dx. We can get rid of this one. So for that, I have to subtract 1 over x positive y from both sides. When I do so, let me finish my working. So this positive term, negative term will cancel out. I'm just getting 1 over x positive y times dy over dx, negative dy over dx. On the right side, I'm getting 1 negative 1 over x positive y. Okay, now I can factor dy over dx from the terms on the left side over here. So when I factor dy over dx, I'm getting 1 over x positive y, negative 1. Okay, on the right side, I'm going to factor negative sign from these two terms. So whenever I factor negative sign from the terms of an expression, the original sign of the terms will change. So if I factor negative sign, so this term has negative sign over here, so it will become positive. That is positive 1 over x positive y. And this term is having positive. Since I factor negative sign out, it will become negative 1. So if I distribute this negative sign to this one and this one, I must be getting this stuff, original stuff. So when I distribute negative sign to this one, I'm getting negative 1 over x positive y, 1 over x positive y. When I distribute this negative sign to this negative one, it becomes just 1. Well, so why should I factor negative sign from this expression? So because to get exactly the expression what we have on the left side, so that I can divide by 1 over x positive y negative 1 on both sides, I can simplify easily. So I just want to get the expression over here on the right side. That's why I factor negative sign from this expression. Only if I factor negative sign from the expression on the right side, I'm getting the same expression on both sides. Okay, now 1 over x positive y negative 1 and dy over dx are multiplied. Since we want to find dy over dx, let's divide both sides by 1 over x positive y negative 1 on both sides. Let me complete. Okay, so this one will cancel, and also here also this one cancel. This 1 times on 1 times. So dy over dx equals to, on the right side we have negative sign. 1 over 1 is just 1. So the derivative of the given function with respect to x is negative 1.